Hi, my name is Ben Owens. In this video, we're going to look at the normal distribution. Many of the most important ideas in statistics are based on or use the normal distribution. We're going to be studying the inferential statistics, and many of the ideas therein use the normal distribution in meaningful and powerful ways. Earlier this semester, we saw that the normal distribution could be used to describe data that follows a bell-shaped curve. Let's recall the types of questions that we could answer from that. Example 1. Here we want to use the empirical rule to answer the following questions. Suppose that final grades in a course are found to be approximately normally distributed with an average of 78 and a standard deviation of 7. The question we want to answer is about what percentage of students made between a 64 and an 85. If you remember, the normal distribution is centered on the average, and so therefore the middle number here in the normal distribution will be the average, and then each step to the right and left will be a step of size 7, which is the standard deviation. So here, if we take one step to the right, that's going to be 85, another step is 92, and then 99. If we take steps to the left of 7, that will give us 71, 64, and 59. In order to solve this problem, we have to use the empirical rule for normal distributions. The empirical rule, remember, said that 68% of the data fall within one standard deviation of the average, and that 95% of data fall within 2 standard deviations of the average. And even more so, 99.7% of the data fall within 3 standard deviations of the average. So the way that we can use that to solve this problem, how many students made between 64 and 85, is to find the areas in those regions. So here, of course, we're looking at finding the area from here, 64, all the way to 85. Now, unfortunately, this region is 2 steps to the left, but only 1 step to the right. And so in order to solve that, we have to kind of piece things together. Here may be one way you could do that. If you take the part B here of the empirical rule, and you say, well, 95% of the data are going to be between 64 and 92, and divide that by 2, that's just going to be the region that's here, between 64 and 78, and that's 47.5%. If you do the same thing with the 68% between 71 and 85 and split that into 2, that gives you this region. So adding those together gives us the total percentage between 64 and 85, which is 81.5%. Let's look at one more example about what percentage of the students are going to score above an 85. Here, we're looking for this region that's above this. Oftentimes, when working with the normal distribution, we're going to shade the regions that we're talking about. So that might look like this. The region underneath the curve shaded to the right of 85. Now, in order to solve this, one way of doing that would be to first find the region that's in between 1 and -1 standard deviation. That, of course, is 68. If we subtract that from 100, we get 32, and that's the amount that's left on either side. So between this portion over here and this portion over here, that's 32%. Since we only want the portion on the right, we simply divide that by 2, and that gives us that we would expect 16% in this region. Oftentimes, students will notice that you can split up the normal distribution into these regions. So if you're asked to find a certain percentage between 2 of these values, it's simply a matter of adding up those pieces. So here is another similar problem. About what percent of the class made a B? Now, unfortunately, we can't use the empirical rule to solve this problem because the grades corresponding with making a B, which of course means making between an 80 and a 90, don't line up exactly on 1 and 2 and 3 standard deviations away from the average. To solve this question, and questions like it, we need to use the normal distribution table. The normal distribution table is going to give us values of areas under the curve of the standard normal distribution. The standard normal distribution is the normal distribution that has the average of 0 and a standard deviation of 1. The random variable that we give this standard normal distribution is called z, and sometimes we even call this the z distribution. So in the next example, we're going to see how to use the standard normal distribution table to answer questions. The standard normal distribution table is going to give us the area under the curve to the left of a given point. So let's do this. Our guiding question here is going to be to find the area under the curve to the left of 1.53 on the standard normal distribution table. Now, of course, that means that we're trying to find the area to the left of this point. The way that we typically write this is to say the probability that z is less than 1.53 is equal to whatever we're looking for. This is just a fancy way of saying what is the area to the left of 1.53. In order to solve this, we use this normal distribution table. The way that this table works is it splits up numbers into two parts. The number in question, of course, is 1.53. The first part of this number, that is the units place and the tenths place, are going to be found in this left column. The number in the hundredths place is going to be found in the first row at the top. In order to find the area to the left of 1.53, we simply find 1.5 on the left and 0.03 at the top and see where those two coincide. That number tells us the area to the left of that point. In this question, the answer is 0.9370. So the area to the left of 1.53 is 0.9370. You could also say that about 93.7% of the area is below 1.53. Let's practice finding the area to the left of various numbers. Go ahead and pause the video at this point, and then when you're done, resume. All right, you should have got the area to the left of negative 2.44 is 0.0073. The area to the left of 1.08 is 0.8599. The area to the left of negative 2.5 is 0.0062. And the area to the left of 0.06 is 0.5239. I'd also like to take this moment to point out an interesting fact. Since the normal distribution is a continuous distribution, it doesn't matter whether we use strictly less than or less than or equal to. It makes no difference in the answer. In this next example, we're asked to find the area to the right of a certain number. Now, in this case, the area to the right of 2.43 is this little bitty bit right here on the right. Now, the notation that we use for this is to find the probability that z is greater than 2.43. So when we're trying to find the area to the right, we'll always use greater than. Now, the normal distribution table is only going to give us the area to the left of a certain number. And so in order to solve problems like this, we have to use the complement. Notice that the area to the left of 2.43 is the complement of the area to the right. In other words, if you take the area to the left and subtract it from 1, that will give you the area to the right. The total area under the curve is 1. So, in order to find the area to the right of 2.43, we take 1 minus the area to the left of 2.43. Now notice this number is one that we can find on the standard normal distribution table. That is, we're going to look up 2.43. Whatever that number is, which is 0.9925, when we subtract that from 1, gives us our answer. Notice here, we knew that the answer needed to be rather small, and so it makes sense that our answer is 0.0075. That's less than 1%. Now here's a cool shortcut for finding the area to the right. If we want to find the area to the right of, say, 1.59, here is what we can do. There's this fact about the normal distribution, and that is that the normal distribution is symmetric, meaning that it looks the same on the left as it does on the right. What that means is this. If we find the probability, or if we want to find the probability of what's to the right of 1.59, that's going to have the same area as to the left of negative 1.59. So finding the area to the right of this is the same as finding the area to the left of negative 1.59. That is, if we want to find the area to the right of something, we can simply look up the negative version of that on the normal distribution. Of course, if the number in question was negative to begin with, we would have to look up the positive version, so whatever the opposite sign is. Now we're going to look at how to find the area between two numbers. In this problem, we're asked to find the area between negative 1.41 and 0.5. That region would look like this. The way we notate this is to say we want to find the probability of being between negative 1.41 is less than z is less than 0.5. This means that z needs to be between these two values. To find the area between two values, you find the area to the left of the bigger value and then subtract the area to the left of the smaller value. This is how it works. If we first found the area to the left of 0.5, it would give us this region from 0.5 all the way back. Looking up that number on the normal distribution table, we see that it's 0.6915. The problem is we have this area to the left here that's kind of extra. We need to cut that out. So how big is that area? Well, that's simply the area to the left of negative 1.41. So if we look up negative 1.41 on the normal distribution table, we get 0.0793. We need to subtract that amount away. Subtracting those two leaves us with the area in between, which in this case is 0.6122. Let's practice some more. I'll give you about 45 seconds to do these. All right, on the first one, you should have gotten 0.9991. On the second one is 0.0480. The third is 0.4641. And finally, the last one is 0.0677. Here is an interesting thing. Let's find the area between negative 1 and 1 and the area between negative 2 and 2. The empirical rule has told us that these numbers should be 68%, 95%, and 99.7%. Let's see if that's actually the case. I'll give you about 30 seconds to do those. As you might have seen, The numbers aren't exactly 68% or exactly 95, but they're very close. Here is a chart showing each of these regions split up more precisely. So let's go back to the guiding example that we looked at the beginning. Suppose the final grades in a course are found to be approximately normally distributed with an average of 78 and a standard deviation of 7. About what percent of the class made a B? Now, of course, making a B means you're going to be somewhere between 80 and 90. And so, in order to solve this problem, we need to find the area between 80 and 90 under this normal curve. Now, the problem is we can't use the standard normal distribution table directly because this situation does not have an average of 0 and a standard deviation of 1. However, we can translate this problem into a similar problem that does use the standard normal distribution table. Here is how we do that. Notice in this case, 78, which is in the middle, is the average. Well, on the standard normal, that's just going to be 0. 85 would be 1, 92 would be 2, and so on and so forth. What we want to do is area between 80 and 90. So we need to find the corresponding numbers that would be here, say, between 0 and 1. I mean, clearly 80 is between 0 and 1, so we would expect that this is, somewhere like point something. And then, 90 is somewhere between 1 and 2, and so this is going to be 1 point something. But how do we find that value? Well, if you think about it, what this is actually asking is, how many standard deviations away from the average is 80? And so how we would solve that is we use the z-score. To find how many steps away each of these numbers are from the average, we use the z-score. Now remember, our z-score formula was that z is equal to x minus the average divided by the standard deviation. So the z-score for 80 is 0.29, and the z-score for 90 is 1.71. Which is kind of what we had expected. We knew that this was going to be somewhere between 0 and 1, and this was going to be somewhere between 1 and 2. The z-score formula allows us to find precisely what those numbers need to be. So, finding the area between 80 and 90 is going to be the same as finding the area between 0.29 and 1.71. So how we would write this is that we want to find first the probability that x is between 80 and 90. X is this random variable that has the normal distribution with the average of 78 and a standard deviation of 7. Well, that is equivalent to finding the probability that z is between 0.29 and 1.71. Now we can use the normal distribution table to find those values, which will give us 0.342. Let's do the following problem for practice. Take as much time as you want. Press pause before this, and when you're ready, when you've answered each of these parts, then unpause it and we can go through the answers. All right. On part A, we wanted to know the percentage of students that scored below a 60. So that is, we wanted the probability that x is less than 60. In order to solve this, we need to find first the z-score, which is -1, and then find the probability that z is less than that, and you should have gotten 15.87%. On part B, we're trying to find the probability that a student made an A, which is anything bigger than 90. Now, here we need to find the z-score of 90, which is 1.31, and in order to find the area to the right of that, remember we can find the area to the left of negative 1.31, and that's equal to 0.0951. In part C, we're trying to find the area that is between 75 and 85, and so we need to find two z-scores. This will translate into the probability of z being between 0.15 and 0.92, and the final answer there is 0.2616. Whenever a problem says the data set is approximately normal, it means that if you were to make a histogram, it would more or less follow a bell-shaped curve. Now, one thing that's important to realize is that the data don't need to be perfectly bell-shaped in order to use the methods that we've described in this presentation. But the closer the curve is to normal, the better. I hope this video is a nice introduction into using the normal distribution. Thanks for watching.